Part 1. The hidden power of blood. How exercise transforms more than muscles. When people think about the benefits of exercise, they usually imagine stronger muscles, a leaner body, a healthier heart, or more stamina. But there's one powerful system working silently behind the scenes: your blood. This vital fluid does much more than carry oxygen and nutrients. It adapts in extraordinary ways when you commit to regular exercise, and these changes can dramatically impact your performance, health, and recovery. Most of us associate exercise benefits with what we can see or feel externally: toned arms, a faster mile, improved sleep. But beneath the surface, something even more fascinating is happening. Your circulatory system is being remodeled. And at the center of this transformation is your blood. Exercise initiates a cascade of responses throughout the cardiovascular system. As you begin to move, your heart rate increases, your arteries expand, and blood flow is redirected toward the working muscles. But with continued and consistent training, the body begins to adapt. These adaptations aren't just short-term responses, they're long-term upgrades to your internal systems. Among the most critical of these is how your blood responds and changes. You might not realize it, but regular physical activity actually alters the structure, volume, and composition of your blood. It becomes more efficient at delivering oxygen, transporting nutrients, removing waste, and even regulating body temperature. These changes are not just helpful for athletes, they're essential for anyone who wants to improve their overall health, longevity, and physical function. This article explores how consistent training can increase your blood volume, stimulate the growth of red blood cells, and expand the microscopic capillaries that deliver oxygen deep into your muscles. It also examines the types of exercise that produce these changes most effectively and how you can incorporate them into your own routine, no matter your fitness level. So while it's easy to focus on visible gains, don't forget the invisible ones. Your blood is evolving with every workout. By understanding and embracing these changes, you can unlock a new level of energy, resilience, and performance that extends far beyond the gym. Part 2. Capillaries, the microscopic highways of performance. To understand how blood changes with exercise, we must first zoom in on the smallest, but perhaps most vital component of the circulatory system: the capillaries. These microscopic blood vessels are the crucial connection points between your blood and the tissues it serves. They're not just passive channels, they are where the real magic happens. Each capillary is so narrow that red blood cells must pass through in single file. Despite their size, capillaries are powerful. This is where oxygen, glucose, amino acids, and other essential nutrients are exchanged from blood into muscle cells. In turn, waste products such as carbon dioxide and metabolic byproducts like lactate are removed from those cells and shuttled back into circulation for elimination. So, what happens to your capillaries when you start exercising regularly? Quite simply, they multiply. This process is called capillarization, and it's one of the earliest and most profound adaptations your body makes in response to endurance training with consistent aerobic activity. Your muscles literally grow a denser network of capillaries. Think of it as upgrading from a 2-lane road to a 5-lane highway. It drastically improves traffic flow, which in this case means faster oxygen delivery and waste removal. Why does this matter? The more capillaries you have, the more oxygen-rich blood can reach your muscle fibers. This is especially important during extended bouts of exercise when your muscles need a continuous and efficient supply of fuel. Capillarization not only enhances endurance, but also accelerates recovery by helping clear metabolic waste more quickly. Scientific studies support this. Research published in the Journal of Applied Physiology found that trained endurance athletes have significantly greater capillary density in their skeletal muscle compared to untrained individuals. This enhanced capillary network improves diffusion capacity, oxygen delivery, and muscular efficiency. Importantly, capillary growth doesn't just help elite athletes, it benefits anyone engaging in regular aerobic activity. Whether you're walking briskly, swimming laps, or cycling to work, Your body is remodeling itself to become more efficient, and it starts with these tiny vessels. Capillarization is your body's way of saying, "I'm ready for more," and once this system is in place, it lays the groundwork for even greater cardiovascular adaptations, especially in your total blood volume and red blood cell production. Part 3. Blood volume and plasma expansion, building a more powerful circulatory engine. Once your body begins expanding its capillary network through regular training, the next adaptation becomes both necessary and inevitable, increasing the total volume of blood. After all, more capillaries mean more space to fill in, and your body is incredibly smart about meeting that demand. The total volume of blood in your body is made up of two primary components: the plasma, the fluid portion, and the cellular elements, which include red blood cells, white blood cells, and platelets. Plasma accounts for about 55% of your total blood volume, and it plays a vital role in transporting nutrients, hormones, and waste products. It also helps maintain blood pressure, regulate body temperature, and support immune function. So how does exercise influence the system? With consistent training, especially aerobic exercise, your plasma volume increases significantly. This is one of the earliest adaptations to regular physical activity. Within just a few weeks of training, your body begins to retain more fluid and electrolytes, expanding the liquid portion of your blood. This process enhances your ability to deliver oxygen and nutrients more effectively, while also cooling the body more efficiently during workouts through sweat and thermoregulation. A landmark study published in Medicine and Science in Sports and Exercise by Dr. Victor Convertino demonstrated that plasma volume can increase by up to 20% after only 10 to 14 days of aerobic training. This expansion boosts stroke volume, the amount of blood the heart pumps with each beat, meaning your heart doesn't have to work as hard to deliver the same amount of oxygen. But there's another crucial benefit. More plasma creates an environment that supports the production of more red blood cells, which we'll discuss in the next section. Think of plasma as the river and red blood cells as the boats carrying oxygen. Without enough water, those boats can't move efficiently. By increasing plasma volume, your body essentially upgrades its entire cardiovascular system, making each heartbeat more efficient and each workout more productive. And while you might not see these changes in the mirror, you'll certainly feel them in the form of increased endurance, reduced fatigue, and faster recovery times. This invisible but powerful shift in your blood sets the stage for the next step in your body's transformation: increasing the number of oxygen-carrying red blood cells. Part 4. Red blood cells and oxygen-carrying power. Once your plasma volume increases, your body doesn't stop there. To make the most of that expanded circulation system, it starts producing more red blood cells, RBCs, the specialized cells responsible for transporting oxygen from your lungs to your muscles and tissues. Each red blood cell contains hemoglobin, a protein that binds to oxygen molecules and delivers them wherever they're needed. When you exercise regularly, especially with endurance-based activities, your body gets the signal that more oxygen is required. In response, it stimulates erythropoiesis, the production of new red blood cells within the red bone marrow located in bones like the femur, pelvis, and sternum. This isn't just a small uptick. Over time, trained individuals often have a significantly higher hematocrit, the proportion of red blood cells in the blood, and hemoglobin concentration compared to untrained individuals. This allows for greater oxygen delivery to muscles, enhancing aerobic metabolism and delaying fatigue. This adaptation is also why many elite endurance athletes train at high altitudes. The lower oxygen levels at elevation stimulate the production of erythropoietin, EPO, a hormone that tells the bone marrow to produce more RBCs. While altitude training is a specialized method, regular aerobic exercise at sea level also boosts red blood cell count effectively over time. Ultimately, more red blood cells mean your muscles receive more of what they crave: oxygen. This fuels the production of ATP, the energy currency of your cells, allowing you to perform better, last longer, and recover faster. It's another invisible transformation with a massive payoff, one heartbeat at a time. Part 5. The role of exercise types in blood adaptation. Now that we understand how exercise influences capillaries, plasma, and red blood cells, the next question is, what types of exercise create the most powerful blood-related adaptations? The answer depends on intensity, duration, and consistency. Among all types of training, aerobic endurance exercise is the most effective stimulus for expanding blood volume and improving oxygen transport. Activities such as running, cycling, swimming, rowing, or brisk walking when performed regularly at moderate intensity encourage capillary growth, boost plasma volume, and stimulate red blood cell production. One of the most powerful tools within endurance training is what's known as zone to cardio. This is a level of effort where you can still hold a conversation while exercising, typically around 60 to 70% of your maximum heart rate. Training in this zone is low enough in intensity that it can be sustained for long periods, but intense enough to push cardiovascular adaptations. Zone to training helps increase mitochondrial density, improve fat oxidation, stimulate capillarization and blood volume expansion, support recovery by reducing inflammation. The low intensity also allows you to accumulate a high training volume without causing overtraining or burnout, crucial for long-term fitness and metabolic health. But endurance exercise isn't the only pathway to blood adaptation. High-repetition strength training, often referred to as strength endurance, also plays a role. Exercises like bodyweight squats, push-ups, or resistance band work performed for 15 to 20 plus reps challenge both muscular and cardiovascular systems, promoting local blood flow and encouraging vascular adaptation within the trained muscles. Even high-intensity interval training can contribute, especially in improving VO2max and stimulating some capillary growth. However, due to its intense nature, HIIT is best used sparingly and complemented with lower intensity work. Ultimately, the best strategy is a balanced training program that includes zone to endurance, strength endurance, and occasional high-intensity sessions. This comprehensive approach ensures you're stimulating the full range of cardiovascular and hematological adaptations, leading to better performance, greater energy, and stronger overall health. Your training choices shape your blood, and your blood, in turn, shapes your ability to train, recover, and thrive. Part 6. Blood adaptation for strength and power athletes. You might be wondering, if most of these blood adaptations are driven by endurance training, do they matter for strength or power athletes like weightlifters, sprinters, or basketball players? The answer is a resounding yes, though the benefits might look a little different. While increased blood volume and capillarization might not directly improve your 1-rep max or explosive vertical jump, they play a crucial role in something just as important: recovery. During intense anaerobic efforts like heavy lifting or sprinting, you're fast, which muscle fibers generate a significant amount of metabolic byproducts, especially lactic acid. Here's where blood adaptations come into play. The slow-twitch muscle fibers, which are rich in capillaries and rely heavily on oxygen, can help clear these byproducts more efficiently, but only if they're well supplied by blood. In other words, a more vascularized, oxygenated muscle recovers faster between sets, rounds, or plays. This means that strength and power athletes can benefit from sprinkling in low-intensity cardio or high-rep strength endurance training to improve blood flow and waste clearance. Even a couple of weekly zone-to sessions like cycling, rowing, or inclined walking can enhance your ability to recover between explosive bouts and reduce fatigue during training or competition. Additionally, these adaptations help regulate body temperature, control inflammation, and improve sleep quality, all of which are vital for performance and injury prevention. You don't need to become a distance runner, but by supporting your cardiovascular system through smart, minimal endurance work, you create a more efficient internal environment for strength gains, faster recovery, and long-term athletic development. Part 7. Long-term health benefits of better blood. While much of the discussion around blood adaptations focuses on performance, the impact of these changes goes far beyond the gym or playing field. In fact, one of the most compelling reasons to support healthy blood function through exercise is the profound effect it has on long-term health and disease prevention. When you improve your blood's composition and efficiency through regular physical activity, you're making systemic changes that affect nearly every organ in your body. The benefits are numerous, well-documented, and far-reaching. 1. Cardiovascular protection. An increase in plasma volume and red blood cells reduces the workload on your heart by allowing it to pump more blood with each beat. This leads to lower resting heart rates and reduced blood pressure. Capillarization also helps regulate blood flow to critical organs. Collectively, these adaptations lower your risk for heart disease, stroke, and atherosclerosis. 2. Improved metabolic health. Efficient blood flow ensures that insulin and glucose are delivered promptly to tissues that need them, enhancing insulin sensitivity. In fact, regular aerobic exercise is one of the most effective non-pharmacological interventions for preventing and managing type 2 diabetes. More oxygen to muscles also means better fat metabolism, which helps with weight management and reduced visceral fat. 3. Stronger immune function. Exercise-induced changes in blood also stimulate the movement of immune cells, such as lymphocytes and natural killer cells, enhancing the body's ability to respond to infection and inflammation. Increased circulation acts like a surveillance system, allowing immune cells to travel efficiently and detect threats early. 4. Cognitive and mental health. Better blood flow to the brain means improved cognitive function, memory, and mood regulation. Exercise stimulates the release of brain-derived neurotrophic factor BDNF, which supports neuron growth and repair. Increased cerebral circulation is also linked to a lower risk of Alzheimer's and other forms of dementia. 5. Hormonal balance and recovery. Improved circulation aids in the transport of hormones and removal of metabolic waste, helping regulate stress responses and supporting faster tissue repair. This contributes to better sleep, lower inflammation, and enhanced physical and mental resilience. In essence, when your blood flows better, everything else functions better. Exercise doesn't just transform your fitness, it upgrades your entire biology. It's a low-cost, high-reward investment in lifelong vitality. Part 8. Practical strategies to enhance blood adaptation through training. Knowing how exercise changes your blood is empowering, but how do you actually apply this knowledge in real life? The key lies in building a smart, balanced training routine that supports your cardiovascular system, encourages efficient oxygen delivery, and enhances overall blood health. 1. Incorporate Zone 2 cardio regularly. One of the most effective ways to stimulate capillarization and increase plasma volume is to perform Zone 2 cardio consistently. Aim for 3 to 5 sessions per week, each lasting between 30 and 60 minutes. Examples include brisk walking, cycling, swimming, or even hiking activities where you can still maintain a conversation while moving. This low to moderate intensity allows your body to adapt without overwhelming your recovery systems and supports long-term endurance and metabolic flexibility. 2. Add strength endurance sessions. In addition to traditional resistance training, include 1 to 2 sessions per week focused on high-repetition movements such as push-ups, bodyweight squats, lunges, or light dumbbell work. Keep the rep range high 1520+ and rest periods short to encourage vascular adaptation in muscle tissues. 3. Stay well hydrated and eat smart. Hydration is essential for expanding plasma volume. Drink water regularly and include electrolytes, especially if training in hot environments. For red blood cell production, ensure you're consuming adequate iron, folate, vitamin B12, and protein nutrient crucial for erythropoiesis. 4. Train consistently, not aggressively. Blood adaptation is about sustainable stress. Overtraining can suppress recovery and hinder cardiovascular gains. Focus on steady, long-term progression rather than pushing to the edge every session. By applying these strategies, you're not just getting fitter, you're building a stronger, more efficient internal system. Your blood will carry the results, quite literally, to every cell in your body. Part 9. Final thoughts. Blood doesn't lie. In a world where fitness is often judged by appearances, muscle size, body fat percentage, or the number on a scale, it's easy to overlook the deeper, more meaningful transformations happening inside the body. But if there's one thing we've learned, it's this: blood doesn't lie. Every time you exercise, you're triggering changes that ripple throughout your circulatory system. Your heart grows stronger, your capillaries multiply, your plasma volume expands, your red blood cell count rises. These changes don't just help you lift more or run further, they're investments in your longevity, recovery, and resilience. Unlike external transformations, these blood-based adaptations aren't always visible, but their impact is profound. They support your immune system, protect your heart, sharpen your mind, and fuel your energy day after day. They allow you to live, move, and feel better at every stage of life. And the best part, these changes are available to everyone, not just elite athletes or weekend warriors. Whether you're walking your dog, biking to work, lifting weights in your garage, or taking a dance class twice a week, you're telling your body, let's evolve. So instead of chasing quick fixes or surface-level results, shift your focus inward. Understand that each drop of sweat is part of a larger process, a transformation of your internal environment, led by your blood, because long after the soreness fades and the mirrors stop mattering, what remains is a healthier, stronger, more capable version of you. And it all starts with the bloodstream quietly, powerfully, doing its work behind the scenes. Train wisely, recover well, and remember, when it comes to your health, your blood reflects your effort more than anything else. If you found this video insightful and it helped you see your body and your blood in a whole new light, don't forget to give it a thumbs up. It really helps us reach more people who care about taking control of their health from the inside out. And if you'd like to see more content like this backed by science, explained clearly, and focused on real transformation, then make sure to subscribe to the channel and hit the notification bell so you never miss an update. Your journey to a stronger, healthier, and more resilient body starts here. Thanks for watching, and we'll see you in the next one.